All right, happy Friday. We made it through our first e-learning week, and there's 5 more to come. So we're going to stay with similar figures. It's been a struggle. I've looked at some of the scores on Khan and quizzes. We're going to keep at it today and Monday, so hopefully for some of you that are struggling, it'll start sinking in. But let's get to something you do know. With sides, we said that the corresponding sides or the matching sides are proportional. Well, this is a proportion. If you remember what we did back in January, and we solved these, right? So to solve these, all we do, if we want to solve for x, no matter where the x is, we always multiply diagonally, and we divide by the third number. So if I wanted to solve this proportion, I would take 30 times 42, whatever that is, divide it by 14, use your calculator. So why do we need to know this today? Because that's what we're going to set up when we solve these similar figure problems. All right, so let's do a little bit of a review. So the next one. So you're going to see triangles, rectangles. I think mostly what you're going to see is triangles, but we could have parallelograms. I mean, we can have anything that's similar. We could have a pentagon that's similar, and we can still find the missing side. So what you saw on your quizzes today and what you saw in Khan yesterday was you were finding like corresponding parts, matching parts. Is it similar? What do you do to find out? What do you need to know to find out if it's similar? So in summary, basically what you've done in the last 2 days is you've looked at two figures and you've decided whether they're similar. Here's your similar symbol. First thing that has to happen is matching angles have to be equal or congruent. Matching just means corresponding. So what that means is a figure is similar if its matching angles are equal or its corresponding angles are equal. Well, you see this by the arcs. So this matches this angle. Two arcs. Where's my red marker? This has two arcs. You just don't see it. There's two arcs there. And one arc and one arc. So these angles do match, and that's the first condition for two figures to be similar. The other is that matching sides have to be proportional, not equal. If the angles were equal and the sides, matching sides were equal, then we would have two equal, exact, same looking triangles here, and these are not. These are similar. So what happens is our matching sides actually form this proportion. So we just look at them as three different ratios. We've got side AB. AB here. Its matching side is DE here. That fraction should be the same fraction as this matching side, which is BC, this one, and EF, this one. That should also match our third, which is AC and DF. What that means is, no, are these sides equal? Absolutely, they're not equal. They don't look equal. But what they are is they do have something in common. All these fractions, if we had sides lengths for each of these, if we put numbers in for each and divided them all, they would be the same exact number every time. That's what it means by proportional. So what we're going to do today is we're going to figure out how the heck do I find a missing side. So they're going to have on the triangle, if it's a rectangle, whatever it is, they're going to have one side that they're asking for. So on this one, they want to know what is the length of this. Well, how the heck do you do it? Well, we set up a proportion. So I'm going to leave this here. I got to get my marker because I got to write on my other whiteboard. All right, so I've got another whiteboard. I'm going to try and keep this here and write on the other one at the same time. So this is really the key right here, what we're doing. This is how we're going to solve these problems. So when they give us two figures, okay, I'm going to see if I can balance that. Well, all right, we'll do what we can. So we have a small triangle and a large triangle. We don't know this side length. So we set up that proportion here. So I'm calling this is the small triangle. That's what small stands for. Big is the big triangle. You could put big on top and small on the bottom. It really doesn't matter where you put the big and the small. The key is that your sides across, those both better be on the small triangle, and these sides across both better be on the big triangle. So what you do, and the way I tell students to do this problem is, we first find out what's the side length we don't know. Well, it's X, and that is on the small triangle. So I always go to what am I missing first? Now, what side matches side EF? Well, you go to your big triangle. That is side BC. So now side BC is 15. That is our first ratio. X matches 15, and now all you need is another two sides that you know. So it's got to go small to big. If they gave you this side and this side, you use these two, but it gives us this 4 and this 12, so we're going to put 4 matches 12. That is a proportion that we can now solve. So we have got our matching sides. our x matches our 15, 4 matches 12. We've got what we needed from this. And now you go to here, you multiply diagonally, and you divide by the third number. And you get what that answer is actually 5. Okay. Well, you would see 5 divided by 15 simplified is 1/3. 4 divided by 12 simplified is 1/3. It's the same thing. So if I went big to small, I'd have 15 over 5 and 12 over 4. Well, those would simplify to 3. That's where you get your scale factor too. All right, that's where you get that scale factor as well. So that's just solving for a missing side. That's your first con assignment. It's just basic. It's called solving similar triangles basic. You got to find your matching sides, get your x, which you don't know, and find 3 other sides, plug it in and do it. Take a hint if you don't know it. Now, let's get to a word problem. All right, word problems. So this is 3 parts: basic, word problems, and the more difficult one on con. So I'll show you one. There's another video on Canvas that I've put. That's not me, it's somebody else. Walks through these types of problems as well the same way. All right, these are called shadow height problems. So what's a shadow height problem? It says a 10-foot building. You're going to see my artistic skills here in a second. A 10-foot building casts an 8-foot shadow. How tall is a ladder that casts a 28-foot shadow? These are typical similar figure drawings. Because why? Because when we draw the picture, which is what you should do with each of these, you're going to see that we form similar figures. So I'm going to just read that question, what I had here. A 10-foot building cast an 8-foot shadow. How tall is the building that cast a 28-foot shadow? So that, I just drew dotted lines here to show really we basically have 2 triangles here. So we have 2 triangles. We're going to find the missing side. So we need to know how tall is this building. So we're going to go from the building is taller, okay, because it has a 28-foot shadow. So basically you find your missing side.
I thought it was ladder.
Huh?
I thought it was a ladder.
A ladder, what did I say?
Building.
Oh, thanks, videographer. Building. Building, ladder. So we don't know the size of the ladder. What matches that ladder on the building? 10. So we go x over 10. Now we just need 2 other sides. Well, we know both of the shadows. So then we do our 28-foot shadow over the 8-foot shadow. We take basically the words to the picture to basically this. What is the height of that building? Okay, so word problems can seem difficult. I think if you just take the words and write a picture, you're basically going to see kind of what you start with today in con. All right, and then the last and most difficult one. How much time are we at?
8 minutes.
8 minutes. Oh, not bad. Okay, so we've got that. We're down to 2 slides. Here's probably the most difficult type of problems, and this on con says, I think, solving similar figures advanced, or solving similar triangles advanced. Why is it difficult? Because there's a triangle inside of another triangle. So the way that I teach students to do this, yeah, it's kind of hard to see it within a triangle. So if you can visualize it, some of you may see this triangle here, this ABC, that's kind of sitting inside this big one. It's got this side of 8, it's got this side of 7, and then I have this big triangle on the outside, and we have to find this missing side x. What do? I just take this small triangle, I kind of pull it out, so I look at 2 different triangles next to each other. So that's what I've done here. So if you can kind of, on these types of problems, just think, okay, well, I've basically got 2 triangles. This one I've put as my small one. This is the bigger one, although to scale it doesn't really match. So how am I going to do this? Let's do it this way. Okay, so basically I'm just going to transfer the lengths that I know, and this is where you have to take a little bit of math in this one. So this one's not too bad. ABC is right here. I just matched it right here. This side's 8. You should be able to see that. And this side's 7. Okay, all right, not bad, right? 8 and 7, you just take away that's that triangle. Now, if we take away this now, if we can kind of avoid this, we can see now this big triangle. Well, you've got this side and you don't know this side, but it's hard to see when I have that line here, right? Because some students are going to say the length of that big triangle is 5. But when you take this away, because you need to know the total length from here to here, you got to see that you got to add those together. That's the length of the big side right here. So now, once I do that, Here are my four lengths basically, one of which I don't know. On the small triangle, it was 7 to 8. On the big triangle, it's now x to 13. You just got to see that. And like I said, it's hard to see it there. Students are going to make a mistake. They're going to put 5. Well, the length of that long triangle is not 5. There's no way. This is 8 from here to here. So you have to add them together. And now you're right back to a similar figure. We're going to go big to small now. I'm going to call it big to small. I always start with my x. I don't know my x on the big triangle. What side matches it or corresponds it or is going to form a ratio with this? It's 7. And then we go to our other two sides. X over 7 is equal to big to small. You stay in that order, is equal to 13 over 8. We're back to the proportions that we did in January. All right? But you got to be able to find your matching sides or your corresponding sides. They're not equal. What they're said to be proportional. Your matching angles are equal. And there's some quizzes questions that you missed.
But are you not to worry about the A to C or the E to F?
Nope.
Oh,
Thanks.
okay.
Once you have your X, you have one side that matches X. You just need other two sides. They may have given you these two sides. They may have said this was 26 and 14. Well, then you put 26 over 14. You just need one other set of sides that you know. All right, so it was 13 over 8. Solve that proportion. 7 times 13. Divide it by 8. You got your answer. All right, that's what you'll be doing tomorrow. You got the whole weekend. Don't email me. I'm going to use somebody as an example. I had a student today. They were taking pictures of the quizzes questions and telling me they didn't understand how to do this. We talked through it. Don't be shy. All right. This is unique circumstances. You can't raise your hand in class here. All right. So think of that as just raising your hand in class. You send me an email. I don't know how to do this problem. All right. And I'll help you as much as I can. All right. Try Khan. You can do as many times as you want. Take a hint on Khan. There's another video on Canvas. All right. Watch this again if you need to. All right. There's help for you. Just get it. We'll wrap this up come Monday. We're going to move on to scale drawings after that. So, all right. Have a great weekend.
Don't be afraid to reach out to him.
Thanks. All right. We'll see you.